All right. Now here's a think, pair, share. Um, it's kind of more in the tradition of think, pair, shares, where I think of the instruction and the examples as being kind of like learning to ride a bike with training wheels. And think, pair, share activities are ones in the classroom where you can work together. So that's student-centered learning. But then now the training wheels have been taken off. So you can use the previous examples and the previous instruction as a model, but now you're kind of doing it on your own. And so you can see with this thing, pair share, you don't have the calculator screenshots off to the side. So you need to have, practice this enough to, start to develop the skill of knowing how to use your calculator. Okay, so let's take a look at this one. Personal computer use. So a personal computer is used for office work at home, research, communication, personal finances, education, entertainment, social networking, and a myriad of other things. Suppose that the average number of hours a household personal computer is used for entertainment is 2 hours per day. Assume the times for entertainment are normally distributed, and the standard deviation for the times is half an hour. Find the percentage that a household personal computer is used for entertainment between 1.8 and 2.75 hours per day. All right. So let's try and break this down and let's look at our given information. So we're looking at the amount of time for entertainment. That's our random variable, and it's normally distributed. And this was kind of put in there a little bit earlier. Suppose the average number of hours a household personal computer is used for entertainment is 2 hours per day. So average number of hours is 2. So that's the mean, with a standard deviation of half an hour. So that's 0.5. Okay, so we've got a mean of 2 and a standard deviation of 0.5. So let's go ahead and draw what we've got here. All right. Okay, so we have a mean of 2 and then standard deviations of 0.5. So I'm going to go multiple standard deviations up. Let's see if I go 3 standard deviations up. Let me go 3 standard deviations down, like that. Okay, find the percent that a household personal computer is used for entertainment between 1.8 and 2.75. So we want the probability between 1.8 and 2.75. All right, so 2.75 is right here between 2.5 and 3, and 1.8 is right here between 1.5 and 2. And so what we're looking for is this area in between those two. Okay, so when we've been given values of x and we want to find an area, this is where we need to use a cumulative distribution function, or a CDF function. All right, so on the Texas Instruments calculator, this is going to be norm CDF. And using NumWorks, you're going to use the distribution app. So let's use both. So if we come over here, so let's go ahead and turn this on, clear. All right. So we want to go to the distributions functions. We want to use norm CDF. The lower bound is going to be 1.8. The upper bound, let's see, what was the upper bound? 2.75. And we have a mean of 2 and a standard deviation of 0.5. There we go. So that gives us 0.5886. So the probability is 0.5886 or 58.86%. All right, let's check that here on the NumWorks calculator. So let's come back out. We want to go to the distributions app. Normal distribution. We have a mean of 2, standard deviation of 0.5, and we want the area between two values, and those values are 1.8 and 2.75, and give us the area. Yeah, 0.5886. All right, that looks good. Now, I don't think it looks any different, but let me just check and make sure on older Texas Instruments. Don't think it's going to be. Okay, so this one we have to kind of know what the arguments are here for this. So the lower bound value was 1.8, comma. Upper bound was 2.75, comma. And then that was a mean of 2 and a standard deviation of 0.5. There we go. So I may have to maybe write a calculator function here for this to help things out. But anyway, this is how we can get the same answer with an older Texas Instruments calculator. All right, let's move on to part B. So find the maximum number of hours per day that the bottom quartile of households use a personal computer for entertainment. All right, so we're using the same distribution as before. All right, so let me go ahead and put these values in. Maybe I'll go 3 standard deviations to both sides. Okay, find the maximum number of hours. So what we're trying to find is we're trying to find some value of X that the bottom quartile of households. All right, what's the bottom quartile? That'd be the first quartile, which is the 25th percentile. Okay. So where would the 25th percentile be? Well, let's see. Let's try and reason this out. So using the empirical rule, between +1 and -1, this area between these two is approximately 68%, which means to either side. So let's see, what's 1 minus 0.68? That's going to be 0.32. And so there's going to be 32% on both sides of the tail, which would be 16%. So according to the empirical rule, this area is 16%, and this area is also 16%. So I think to have an area of 25%, we're looking for a value of x that's going to be between 1.5 and 2. Because this area here is 50%. So between 16% and 50% is going to be our percentage of 25%. All right, so since we've been given an area, so the area is given, we need to convert that into some value of x on this horizontal axis, or because we're dealing with percentiles, I'm thinking of it in terms of percentile rank, okay? Some kind of kth percentile. So for this, we want to use like an inverse distribution function, okay? So let's use numworks first for the numworks people. So what we want is we want the area to the left and the area is going to be 0.25. So the value is going to be 1.66. So the number of hours is 1.66 hours, which is the cutoff for the bottom quartile of households. And is 1.66 where we expected it to go? Yeah, we expected it to be between 1.5 and 2. And 1.66 is between 1.5 and 2. All right, Texas Instruments, let's use inverse norm. So the area that we've got is 0.25, the mean of 2, standard deviation of 0.5, and we want this to be the area to the left, 1.66. All right, looks good. All right, so let's go on to part C. Calculate the inner quartile range. Well, put this normal distribution in. Let me go ahead and put my 3 standard deviations above and below. And I just calculated previously at the first quartile was at 1.66. So this area right here is 0.25. Now, what we need for the inner quartile range, that is the third quartile minus the first. Well, we know that the first quartile is at 1.66. That's given. What we need is we need to know what the third quartile is. Well, the third quartile is probably going to be in a similar location between the mean and the first standard deviation, just like the mean and one standard deviation below is where the first quartile was. So I think the third quartile is probably going to be in a similar location. We just need to figure out what this value is. And this area here, remember the third quartile is equal to the 75th percentile. So this area is 0.75. Everything from this value of k on over to the left. So we want the area to the left using the mean of 2 and a standard deviation of 0.5. And let's just change the area to 0.75. And we get 2.33, or just rounding it, we'll round it to 2.34 for simplicity. So that comes out to 2.34. And so 2.34 minus 1.66 comes out to 0.68 hours per week for the inner quartile range. All right. And again, let's take a look. This value of 2.34, yep, 2.34 is between 2.5 and 2. So it was kind of where we expected it to go. All right, good. All right, well, that's the end of all three parts of this think, pair, share. Let me know if you have any questions.